All right, hi folks, this is Larry Mussolino. I wanted to record part 2 to the Module 7 homework video because I wanted to do a few more examples and I wanted to show you again how this Excel calculator can be used to help out with some of the hypothesis testing calculations. This Excel spreadsheet was posted in course announcements and emailed out to you. So please check your email for a copy of this Excel spreadsheet. Okay, it's called Hypothesis Testing Calculator. So if you remember, when you're setting up a hypothesis test, the first step is to really set up this null and alternative hypothesis. Then we're going to calculate what's called a test statistic. Test statistic is like a z-score based on the sample data. Then we're going to find the p-value. Once you find the p-value is a probability, it's an area under the curve. Once we find that p-value, we can come to a decision. And the decision for any hypothesis test is to either reject the null hypothesis or fail to reject. Those are really the only two decisions that you can come to for a hypothesis test. All right, so let's read over this problem to get started here. It says the average height of females in the freshman class has been 162.4 centimeters with a standard deviation of 6.8. Is there reason to believe that there's been a change in the average height? Now, when I see the word change really means the height is different. Well, the word different can really be translated into a not equal symbol. Because if you remember, when you set up the alternative hypothesis, we call it H sub 1 or H sub A, can only have one of three math symbols, a less than, a greater than, or a not equal sign. The null hypothesis, we label that as H sub 0, that always has an equal sign in it. All right, well, the way I'm going to set this up then is for the null, I'm going to say mu equals 162.4. And because they use the word change or different, I'm going to use a not equals here in the alternative. All right, the other thing I need to know here is, am I being given the population standard deviation or not? If you remember, if you're given the population standard deviation, you're going to use the normal distribution. That's section A of this spreadsheet. But if you don't know the population standard deviation, then use the t distribution, and that's going to be section B of the spreadsheet. Well, in this problem, they're giving us the standard deviation historically. That's equivalent to giving you the population standard deviation. So I'm going to use section A in the spreadsheet for this one. Because the population standard deviation is given to us, it's known. All right, so let me come up here. I'm going to start entering the sample mean, the population standard deviation, and the sample size. Remember, in the spreadsheet, you enter numbers in the yellow cells and read the answers in the green cells. All right, so let me go to the wording here, and let's write down the sample data. Well, it looks like we took a sample of 48 females. So the sample size here is 48. We write that as N. So N is 48. The average height was 165.3. That's the sample mean. We write that as X bar. And we're going to use the population standard deviation. We write that as sigma. Population standard deviation is 6.8. All right, so let's go ahead and enter this into the yellow boxes. The sample mean is 165.3. The population standard deviation is 6.8. The sample size is 48. And I'm going to leave alpha as 0.05. Notice in this problem, they did not give us a value for alpha. Alpha is the level of significance. When you're not given a level of significance, 0.05 is a typical value you can use. The only other thing I need here is what is the assumed value of the population mean? That comes from the null hypothesis. Well, that's going to be 162.4 for our example. All right, and let's go ahead and grab the test statistic. So the test statistic is right here. Looks like it's 2.95. They want us to round to 2 decimal places. Now the p-value, I got to be a little careful. There's 3 possibilities here. It says use this p-value if the alternative contains a less than. Use this p-value if the alternative contains greater than. Use this p-value if the alternative contains not equals. Our case, our alternative contained a not equals. That means I've got to use this p-value right. So to 3 decimal places, our p-value is 0.003. All right, we got the p-value. I have to go and answer the question, what's the conclusion here? Do I reject the null hypothesis or fail to reject the null hypothesis? Well, let me scroll over here on this calculator and go to the rule, the decision rule we need. So here is the decision rule. All right, what it says is, let me clear a little of this here. It says compare the p-value with alpha. So let's do it. Our p-value is 0.003. The alpha we're going to assume is 0.05. It wasn't given to us, but we assume 0.05. Well, this p-value is a number smaller than alpha, less than alpha. It says right here, if the p-value is less than alpha, then reject the null hypothesis. And if you notice here, when you reject the null hypothesis, there's enough evidence. I'm going to say there is sufficient evidence to conclude there has been a change. So if you reject the null, that means you're really going to find in favor of the alternative. That means there has been a change. And H sub 0 would be rejected for significance levels greater than the p-value, right? All right, so this example, we use section A in the calculator. All right, let's go do another example. So let me find another example that we could do. All right, let's do an example here. This one is number 13. And turns out this example is going to be a hypothesis test for a proportion. You know, a proportion is when you're dealing with percentages or how many out of the total. So let's read this over. It says a research study of illegal drug use among 12 to 17-year-olds reported a decrease in use. All right, so it says, let's say you took a survey and in a sample of 1049 students, 98 said they use illegal drugs. Use a 0.05 significance level to test the principal's claim that illegal drug use in her school is below the national average. Well, I could see up here the national average is 9.7%. Well, notice we're talking about the proportion of students using illegal drugs. So this is going to be a hypothesis test for proportion. So I'm going to scroll down here to section C of this Excel calculator, hypothesis test for proportions. All right, first thing we got to do is set up the null and alternative. Well, I know we're using 9.7% as the comparison, right? Because the principal wants to compare drug use in her school to the current national average, which is 9.7%. And her claim is that it's below or less than. Well, that leads me to this answer, because below the current average is a less than symbol. So that means I want to use a less than here in the alternative. All right, let's go and find the test statistic and the p-value, then we can come to a decision. All right, so let me come over here to these yellow boxes. And I need to put here the number of successes. Now, really, this is the number of people that said yes to my question, are you using illegal drugs? So that's going to be 98 students. Next is the number of observations. This is the total number of students I asked, which is 1049. Okay. Now, I'm going to leave alpha here as 0.05 because this problem did say use 0.05 significance level. And then one more yellow box here. It says, what's the assumed value of the population proportion? Well, for us, that's 0.097. So I'm going to enter 0.097 here. Remember, this value comes from the null hypothesis. All right, well, I have the I have the test statistic right here. So it looks like the test statistic is negative 0.39. And this test, the p-value we want is where our alternative contained a less than. Well, that's this line right here. If the alternative contains a less than symbol, I got to use this p-value. So 0.3477 is the p-value. All right, well, I'm ready to come to a conclusion. So let me scroll down here a little bit and we'll come to a conclusion. Let me go back up here to our little guidance. Okay. And so it says to come to a decision, you have to compare the p-value with alpha. Let's do it. Our p-value was 0.3477. Alpha, remember, that's the same as the significance level. They said use 0.05. 0.3477 is a number much bigger than 0.05. So our p-value is greater than alpha. Well, if the p-value is greater than alpha, then do not reject the null hypothesis. So my decision is do not reject the null hypothesis. So I'm going to either go with answer A or answer D. I know answer B is wrong because answer B said reject the null. I know answer C is wrong. Answer C said reject the null. Well, if you notice in rejecting the null, your conclusion is there is enough evidence. I'm sorry, we're failing to reject the null. Sorry, my mistake here. We're failing to reject the null. If you notice for failing to reject the null, it says there's not enough evidence. So we have to go with this answer that says there's insufficient evidence. So answer D makes sense. All right. Folks, let me do one more example. Let's come to this one because this one is a hypothesis test for a variance. So let's take a look at this one. And let me move this over a little bit. All right. So folks, I'm going to come here to section D because section D is hypothesis testing for variance. All right, so let's read this over. It says, let me move this way a little bit more. All right, it says aflatoxins produced by mold on peanut crops must be monitored. We took a sample of 64 batches, that's like the sample size, and it came up with 24.39 ppm with a variance of 4.25 ppm. Test the hypothesis that sigma squared equals 4.2 ppm against the alternative that sigma squared is not equal to 4.2 ppm. So they're really giving us the setup of the null and alternative. So here's the null, and here's the alternative. All right, and it says find the test statistic to begin with. So I'm going to come over here to section D. Let me type in the first yellow box, the sample variance. Well, in this case, they told us when we took the sample, we had a variance of 4.25. The sample size was 64 batches, so the sample size is 64. They're not giving us a value of alpha, so I'm going to assume it's 0.05. And what's the assumed value of the population variance? This comes from the null. Well, the null is 4.2 ppm. All right, well, I think I have what I need. Here's the test statistic, 63.75. There it is. I got to be careful with the p-value because in this case, our alternative used the not equal symbol. So that means we got to go with this p-value down here, which is 0.8998. That would round to 0.900. And let's go to a decision then. Let me scroll up here a little bit. We want to come to a decision. Well, in our case, the p-value was a very large number, 0.9. When I compare that to alpha, 0.05, 0.9 is way bigger. So the p-value is greater than alpha. If the p-value is greater than alpha, our decision is fail to reject the null, do not reject the null. So here it is, fail to reject the null. We say the test statistic is not significant at the 0.05 level. It means the p-value is much bigger than 0.05. If the p-value is less than 0.05, we'd be saying the test statistic is significant. And because we failed to reject the null, we're going to say there's not enough evidence, not enough evidence. Okay, folks, so I hope this Excel calculator is helpful. It will calculate the test statistic and the p-value for you for these hypothesis testing examples. All right, let me know if you have any questions as you're working here in Module 7.